Yeah, so you should be able to see the screen now. For this particular example, I will use one of the cases which we were setting up in the second webinar of the slice geometry setup. So yeah, so what you can see here is the results as every one of you would see them right after you have finished the calculation. I will start by going through pretty much all of the basics, and then we will also touch up on the filters and some other editing options that we have for the results. But yeah, then from the very top, we can take a look at the play buttons right up here. So actually, if you press the play button for pretty much any kind of simulation, unless it's a steady kind of simulation, you will be able to see how the heat starts to get induced into the workpiece over time. So over here we can see the seconds, at which second we are, and here we can see the time steps going through. Yeah, the buttons which are here next to the play button is either skip one frame, so that's move one time step, or move to the very beginning, very end, or the very beginning. Yeah, you can see. So so in this case, the heating actually happens for 8 seconds in total. So here we are right around 6 seconds, and the heating is continuing up to 8 seconds. Yeah, so right now the heating has gone through. What we can see also after the heating has gone through, here we can see the temperature scale next to it. So here we can see the maximum and the minimum temperatures. One thing about these temperatures, which you can see, so by default, they will be rescaled to the very last time step. So this means at the very end of your heating, it will take the maximum temperature, which it sees somewhere on the workpiece, and the very minimum temperature, which it also sees on the workpiece. If you think about it, so at the beginning of this simulation, actually the starting temperature was 22 degrees. So we actually do not see that now because the workpiece has heated up, like the entire workpiece has heated up past that point. If we want to see the temperature scale to show us the minimum temperature and the maximum temperature throughout the entire simulation, over here on the left, we have the rescale button that rescales the data over to all time steps. And if we click this, press the rescale button. So right now we see that the temperature scale changes, and right now it does actually start from around 20 degrees, and then it goes up to still our maximum temperature. Another neat trick which we have here, you can actually also go through the time steps. Let's say if I would be interested in what's happening at the 3rd second, I can click on it, and right now the temperature scale did not rescale automatically to the 3rd second. But if we want the values on the scale to match the maximum and minimum at exactly 3 seconds, we just go to this button right over here, and we can rescale the temperature data over this to match this particular time step, the minimum and the maximum temperatures. And you can go through the entire simulation like this if you're interested in doing that. Yeah, then and another option which we have here is also to rescale to a custom data range if you want to input the start and the end temperature on your own. Yeah, then for some of the so yeah, moving on to the next thing which we can see here. So we can also change the coloring of the workpiece to not be the temperature, but to be something else. To change this, always like for any kind of also filters that you apply, make sure that you first select the solid here on the left for which you want to choose the which you will want to change something. So here I click on the workpiece, and now I can change it from temperature over to magnetic flux density, over to current density, and so on. Um, yeah, another thing which I can mention before we perhaps move on to the some of the other things, you can also change the color scale, not the color scale, but the color map for the workpiece to have perhaps added in some more colors. So here you can see we only have blue, kind of white, and then red again, which is quite a basic color map. But if you want to, you can click here on the workpiece, press the button here to edit the color map, and here on the right we can see the color map, and we can edit it in a way how we want it to be kind of like changed. So we can actually take the values which we already have here. So let's say here where we have the more or less whiter color, we can move that around. You can see how the temperatures and the colors change here. You can also double click somewhere on here and input your own kind of color. So you can choose from there, let's say, and just scroll around and input it wherever you would like it to be. You can also write in the specific temperature where you would like this color to be in. So let's say I don't know, 300 degrees. And you can like very nicely monitor the temperatures as they are developing. One thing to mention here at the color maps, there's also the option to choose a preset. So if we click here, there's also presets for color maps. We can choose, for example, the jet color map, press apply, close, and we can see how the colors have changed. So it's perhaps not too colorful, but there's a lot more like definition between changes here in the temperature scale. And once again, we can of course modify them, as well as after modifying the color map, we can actually also save it here by pressing this button, save to preset, write in the name for the color map, and you can save it as your own kind of specific color map right over there. While we're at the topic of color maps, I can also show you that right over here on the bottom, you can also limit the number of colors that your like color map would have. So here I can decrease that number, and you can see that it allows kind of like less colors to develop. And you can see the borders more if you make that number kind of smaller. But okay, that's about the color maps. Then moving forward, if we go to the next thing which we can choose here, so we can actually also change the way we view the workpiece. So change it from surface over to some kind of an outline or points, or yeah, another kind of points, surface, or which is also very interesting sometimes for us, we can change it also to be surface with edges, so we can actually see how the mesh looks like underneath the whole underneath our workpiece. Then some other basic things here are the center button. If you sometimes scroll too much away, you can center back onto your parts. And here on the right, we can also change the direction over which we view the whole thing. Yeah, as well as some kind of like rotating by some kind of set degrees. Then, before we move into some of the other filters, another thing which I can mention here. Um, so actually, for this like visualization, if you want to, for example, see everything from the top, you can see that it's sort of like not entirely from the top, because you can see also these like side faces on the inductor or the workpiece and so on. So to better monitor that, you can actually change it from 3D over to 2D view, and then you are for sure right on the top of everything. But okay, I will move to the very end of the heating, rescale the color map. And right now what we'll do, we will try some of the filters which we have here on the right. So yes, some of you might have already tried the create temperature probe and hardening profile filters, but for some of you who have not tried that, I will also go through that. So to create a temperature probe, what we actually have to do, I will first disable visibility for the inductor so it's not in the way. But here for the workpiece, so what we have to do is first click on the workpiece and then select a place where we would like this temperature probe to be located. To do this, we have to press D on our keyboard, D for double, and just click right now on the workpiece where you would like the temperature probe to be made. So let's say I want it to be made right there. And you can see that a pink dot has appeared, and this is where the temperature probe will start and will develop the information in the probe graph. So yeah, as this point is made, now we can just click Create Temperature Probe, and we will see all of the temperatures at this particular point, depending on time. So yeah, so here you can see how the on the x-axis the time and on the y-axis the temperature. So you can also see how they kind of change, depending also on multiple power inputs, as I was changing current actually as this simulation was moving through. So we can very nicely monitor that. Once again, to perhaps make another probe, let's press here D on our keyboard. And oops, that was not the way to go. Press D, and let's make a probe somewhere right over here. Press Create Temperature Probe, and it will create it in that same graph there on the right. Now, for these temperature probes, so you can actually have as many of them as you wish, but to actually change the colors of them, or perhaps make their names more understandable, what we can do, we can click here where we have these probe graphs. Then on the left where we have the probes, I can click perhaps probe 1. And here on the bottom, that's where we will adjust some of the values to change the colors or change the writing which we have for the probes here. For that, I will open up this window a bit more, and then we can move a bit downwards. Here where we start to see some of the values, we actually have to scroll down a little bit more. And here we can see our temperature that has been displayed here on the right. So to change the color, we can click here on the graph. So I can change the color to be, let's say, not red, let's say green. Press OK. We can see how that color also changes on the right. And if we want to, also we can change the legend name, which just means the name on the graph, which let's say temperature on sidewall or something like that. And we can see nicely how that changes there. And similarly, we can also do that for the other probe as well. So just scroll down. Here we can find it, and temperature in the gap. And we can very nicely see how these values change. Other values can be changed here, such as the size of the lettering, which you have, the location of the lettering, if you also want to change that. But that's yeah, that depends on you if you want to change it. Yeah, then I will leave this open here on the right, but we will move a little bit back to the 3D visualization right now. Then the next filter which we have here is actually the hardening profile. So to once again check the hardening profile on this particular workpiece, we just click the workpiece in the pipeline browser and click the hardening profile filter right here. And the hardening profile should develop. In my case, it has developed very nicely. We can see how deep the austenization temperature has been breached. Perhaps if you're working with some kind of like different materials, which of course have different austenization temperatures, you can also select the value here, which you would think which in your case would be the austenization temperature. So you can scroll this, like, let's say, to increase the austenization temperature, and also decrease it if you're working with a different kind of material. The preset value, though, is 800. Yeah. One quite interesting thing about this hardening profile is that we can actually monitor how it's developing depending on time. So if we go back to some like time steps before the very last time step, we will see that the hardening profile will not have developed as much. So if we go, let's say, to 6 seconds, we can see that the hardening profile has actually just began developing. So, and if I press the play button, we will see how it's slowly growing, the places where it first like reaches these particular temperatures, and how the zones and the yeah, hardening is happening. Um, Yeah, then of course you can also, if you want, you can change the coloring of the hardening profile once again here on the left, where you have the coloring, edit, and you can have it in a different kind of color if you wish. Then if I disable the visibility for the hardening profile and we move back to the workpiece, we will right now take a look at some of the more basic filters, but filters which are quite useful to us also to understand if our like simulation is working as intended, or perhaps there's some problems with perhaps the mesh and so on. So what we will be doing now, we will actually be cutting open the workpiece to see how the mesh and how the viscous layers are behaving in this particular case. Why we need that is just so we know if the let's say current density and everything has nicely developed into the workpiece or not. Then to do that, we click on the workpiece here, and right here a little bit higher, we have the option to clip the workpiece. So this will actually cut it open, but it will leave the volume still there, but it will be cut. And then the other option is to have the slice over here. So this will make a 2D slice of our workpiece 3D volume. So yeah, right now I will click on the clip. And the clip originally will show you some kind of a preset value where it would like to develop that clip. If you want to change that, you can click on the box here and move it around, so you can have the clip develop at some other point. You can also change the way how the arrow is pointed to also move it in some kind of a different axis direction. Me personally, I like to use these X normal, Y normal, or Z normal plane presets. So what will happen if I click here is that it goes to a normal of some kind of a plane, so Z, Y, or X. In this case, I will actually use the Z plane as this will allow us to more nicely see what's happening with the viscous layers. So yeah, let's press apply. Right here, the first thing that you see is that it automatically applies the current density for this clip. We can change it back to be the temperature if we want to. And some additional things here. If you scroll a bit down, we can also invert it. So right now you can see that it has taken away the bottom part of the workpiece, but if we want it to be switched, we can disable the inversion. And right now we can see the bottom of the workpiece, as well as the crinkle clip option, which is something interesting to take a look at sometimes, as it shows you how the mesh elements actually look like if you would clip them there, but the mesh elements would still remain kind of solids. So you can see the triangles that have developed right over there. But yeah, the thing which we will be taking a look at will be the current density actually in this clip. So yeah, let me change it back to be the current density, and to monitor how our viscous layers are behaving. Actually, what we need to do, we need to go to the very first time step. So we go to the 0, then click here to be at the very first time step, and we rescale this current density over to this particular time step. So here we can see the minimum and maximum values, but what we are most interested in is how this current density is developing in the viscous layers. To check, to even see our viscous layers, what we can do on this clip, we can enable the visibility of surface with edges. And right now we can see how the viscous layers actually also look like and if they are sufficient enough. Now I will click somewhere else just so we don't move the clip around, and we can zoom in for the viscous layers and see how they are doing. Um, so a couple of tips here from my side. So basically, the viscous layers, what you should be able to see is that the first element is like a lot redder than all of the other ones, and that the current density slowly starts to soak up into the workpiece. And the perfect variant is that you're using all of the viscous layers very even, like very nicely, and that pattern, so that pattern like changes nicely and slowly. A problem here would be if only the first two elements would be very red. So then we can go back to the manual meshing and make the viscous layers thicker. Or if you see that at the very first time step the current density goes, let's say, this deep into the workpiece, so that's like a lot deeper than our viscous layers are reaching, then of course we can go back and make the viscous layers thicker. Yeah, but for this particular example, just to make it like more nicely visualized, we will be going back to the surface option and enabling the temperature, as the focus of this webinar will be just making the results look good. Um, yeah. Okay. Now what we can kind of start to do is to also like make multiple windows of this like results visualization. So here, let's say for the main window, we can leave the workpiece and the inductor solid. So something like this. So let's say this would be our main window. And let's say here on the right, we want to make an additional window where we would have just the clip or just the hardening profile, for example. To do that, we can go to this window here on the right, and we can split it up either as like this, or we can cut it. We can split it like this. Then when we have split it, we can just go here on the left and enable visibility for, let's say, the workpiece, or as I was saying, the hardening profile. That's something which I would like to see in this case. For the hardened profile, I will leave the color to be solid here, and we will very nicely see how the hardening profile develops over time. If you want to, you can also have the inductor here. If you want to also monitor the current density of the inductor, you can also have that next to the hardened profile, so that there's a bit more color here, and we can see how the inductor is doing as well. Yeah, and here on the left, what we can do. We can either leave it as it is, or we can try to, for example, cut open the workpiece in some kind of an interesting way, so we can see perhaps more of the temperature distribution that's happening inside of it. So just clipping it multiple times, multiple directions, pretty much however you would like to have it. So yeah, so let's say something like this, so we can nicely see how the heat is distributed in multiple levels, let's say. Then what we can proceed with now is, for example, if you would like to make an animation out of these results, you can also do that. Before we make the animation, I would recommend that, well, for some cases it's a lot nicer if you also include some kind of an annotation for time here in the main view, let's say. And to do that, what we can do, here we can go above to the filters bar and go for the alphabetical filters. And you can pretty much find a filter here which is called annotate time, which is right over here. Another way how to find some kind of filters is also if we just go to the if you just press the control space buttons, so Control and space, and the filter search menu will appear. So here I can write in time, and here the annotate time filter should appear, and I can just click on it, press apply, and right here the time has shown up. It's underneath our case name, so I can disable visibility for the case name. And right now we will have some kind of a time annotation. If you want to make, like, let's say, a video afterwards, so that you can also present to your colleagues or your customers or friends at which time step the simulation is at the particular point. Yeah, then to develop some kind of animations, what we can do is go over here to File, and we can go for the Save Animation or Save Screenshot options. So here's Save Screenshot. We'll just let's say I will write in some kind of name here for let's say a front view or something like that. Press OK, and here you have a couple of options for your screenshots. So you can save all views, or you can save just the one that you are in, and you can also change the compression level if you want to have very high quality pictures. But usually this is perfectly okay to just leave it as it is. And yeah, you just press OK, and the image will be saved in the case folder. Similarly, if you go to File and Save Animation, it will be exactly the same thing. Just in the end, you will have multiple pictures, out of which you can make a GIF using some kind of service in Google. I personally, yeah, also like to use Google to find a nice place where to make the GIFs. Yeah, then some of the more advanced filters, or something which I might have not touched upon yet, would be in this particular case, would actually be to have, let's say, to visualize the entire gear. As here we are working with only a slice of gear, so 22.5 degrees of a slice. And if you would like to, you can also have like multiple like let's say we can multiply this solid multiple times, so it looks like we have a full gear here. To do that, we have to once again enter the search menu for the filters, so Control space, and right here we can write in the filter which we need, which in this case is actually transform filter. So this will allow us to move the solid in a way that it looks like we have a full gear instead of just this cut. So I click on the transform filter, and right here on the left you can see the options which we have for this particular workpiece solid. So we can either translate it, so move it, or rotate it. In this case, since our workpiece is directly proportional to the z-axis, I will actually only just rotate it um, in association to the z-axis. So here, what you can see actually, so these first values are the x-axis, some kind of rotation or movement, y-axis movement or rotation, and z-axis movement or rotation. So here, for the rotation, I just input the slice angle, which in this case was 22.5. In your case, it could be 45, 60, 90, or 180 degrees. And we can just press apply. And we can see that the duplicate of our workpiece solid has appeared. Once again, it's shown with current density, but we can re-enable the temperature and also re-enable the original workpiece. So we can see we have already a larger part of the entire gear. And in this way, you would just keep on with this transform filter until you have a full gear. Exactly the same way you can also do that for the inductor. Yeah, then for some of the other filters which I actually forgot to mention, For the hardening profile, I believe that for some of you it would be interesting to see, let's say, how deep the hardening profile has reached into the workpiece, or generally you would like to see how deep some kind of temperature has reached into the workpiece. So to do that, I will re-enable the hardening profile filter right here. And let's say we would be interested in the distance of like hardened depth from here over to here. So this is the end of the hardening profile. So from here to here. To measure this distance, what we need to do is first click on the hardened profile and then click on the ruler option right here. So if we click this, right now, if I zoom out, we can actually see the starting point and the end point of this ruler filter. So what we can do, we can kind of zoom them in to get them closer to our hardened profile and kind of try to move it on top of the workpiece. This can, however, take a bit of time because it doesn't always cooperate as nicely as you would like it to cooperate. So a nice workaround to get the ruler directly on the hardened profile straight away is if we zoom in to the hardened profile, you can actually press Ctrl+1 on your keyboard to place the starting point. So here, if I press Ctrl+1 and my mouse is right over here, the ruler finds a mesh element and develops directly on top of it. So you're 100% sure that it's directly on the mesh and it's not somewhere in the air. Similarly, for the endpoint, we can press Ctrl+2, let's say right over here. Yes, something like that. Let's say, yeah, this will be better. And you can see that the ruler is directly on the on our hardened profile. Then the next thing to do is just press apply, and we can see this value for the hardened profile in millimeters, not millimeters, but in meters. Sorry. But yeah, and then similarly, you can have as many of these rulers as you wish. You can also cut open the hardened profile in some kind of a way with the clipping option, and then also make additional measurements and so on. So you're completely free to do to proceed with this as you see fit. Yeah, then moving on, some of the additional filters which I sometimes like to use. If we disable the visibility for the ruler function, so here on the right, we can actually see the like the filters for temperature probes. So these are temperature probes which are placed directly on the workpiece surface in a single place. But another thing which we can actually do is to plot the temperature over some kind of a line on our workpiece. So let's say we can make a line starting from here over to here, and we will be able to see how temperatures change there on this particular line depending on time. To do that, I will here on the right disable the visibility for these two views, just so you can perhaps see it a bit more clearly. And now to make the plot over line filter appear, we have to go here on the top to the option plot over line, very convenient. And similarly as we had for the previous filter, you can see that the starting and end point is somewhere in somewhere in the air. So we can place it where we need it to be. So here, let's say the starting point will be right over here somewhere, let's say. And the end point, I will just move it manually right over here to the end of the workpiece. So something like this. I usually have it like just a little bit like more into the workpiece to make sure that we're not trying to catch the temperature of the air, which is not going to show up. So yeah, so this line should be okay. We can try to press apply and see if some kind of values do appear. And yeah, here on the right, you can see that the line is okay, that some kind of values do appear, but you can see that the values here are current density, Joule heat, magnetic flux density, and these, at least in my case, is not what I'm looking for. So what I actually can do, go here on the left, scroll down a bit, and here you can see all of the values which are actually shown here. So I can select all of them and deselect them so that we don't have to and try to find them and click away the ones that we don't need. And we just scroll down, find the temperature, and make that visible here. Also, of course, change the color if we wish. And if you wish, also change the name. Yeah, the interesting thing about this filter is, as I said, it will change the temperatures depending on time, but the x-axis is actually the distance here. So this is the starting point for the line, and this is the end point here at the very end. So if I press the play button, you can actually see that at the very beginning, these temperatures here on the left are quite low. The minimum is 22 and the maximum is like 40 degrees or something. And then these temperature values get rescaled as they get larger and larger and larger. So yeah, so this is a kind of a dynamic way to see also the temperatures change depending on time. Also, how fast the temperatures move throughout the workpiece. So let's say from this section to the inner side of the workpiece, we can very nicely see that by monitoring this line, this middle section of the line. So yeah, something like this. So this of course can also be extracted out if you want to make an animation out of this. But if you are only interested in, let's say, monitoring the temperatures on the workpiece, there is an even more convenient way to just check the temperatures which have shown up on the workpiece surface or inside of the workpiece. For this, I will, to show you this, I will go to the very end of the simulation once again. I will, for now, just disable visibility of that chart there. And now I will show you that other option to monitor the temperatures on the workpiece a lot more conveniently. So that option is actually quite simple. It's located right over here, and it's called hover points, like enabling the hover points. And I will click on this, press OK. And right now what actually happens is, as I move my mouse around, I see all of the data at particular points. So I can move it right around here, and I can see the current density, Joule heat, magnetic flux density, and also the temperature. Right there on the bottom, you can see 195 degrees. If I move it here, I can see the temperature is 801 degrees. If I move it here, I can see that the temperature is 1096 degrees. So really just move it around, and you can very easily monitor the temperatures you're achieving. And then you can, of course, understand if any kind of changes need to be made. Is this what you expect or not, and so on. Yeah, to disable that option, once again, just click there, and that option will disappear. Yeah, I'm thinking if yeah, the one thing which I didn't mention yet, but that's not entirely about the 3D visualization. Of course, we also have the time charts option right over here, where we can see the power that we have achieved over time, the current values which I have input, inductance, and voltage as well. As of right now, these are not customizable, but yeah, we're also looking into options. For example, if you would like to see something else here, that you would be able to also see that here. But yeah, actually, from my side, I believe more or less this would be it. Perhaps, yeah, if you have any questions, we can also go over some other things that could be monitored. One thing which I did just realize that we could actually take a look at the magnetic field lines filter. But yeah, if there's any questions, you can also write in the chat box, and um, I will perhaps show you how we can do that. So yeah, so as I said, I just remember that there's a nice filter which we have not yet taken a look at, which actually will show you how the magnetic field lines look like in our simulation. Yeah, to see that filter, actually what we need to do is start off with the airbox, as the magnetic field will actually develop firstly in the airbox. So here, actually, in this case, the airbox is solid 3. For any kind of new cases that you make, there will probably be inductor solid, vortex solid, and also airbox solid available. It will either be called as a solid or as an airbox. But yeah, here you can see how it looks like. And now what we can do, it has already enabled the magnetic flux density, and we can rescale it. So if I press the rescale, it shows us the magnetic flux density that's happening at this particular moment. So these initial color maps, I think they are quite basic. So I always go to the edit the color map option and just change the color map to be more colorful. Let's say the rainbow one. Yeah, so here we can a lot more nicely see how the magnetic field looks like. Before we move on to the magnetic field lines filter, I can also tell you that if you're actually trying to monitor the magnetic field strength, and that's more what you're interested in, actually by just checking the airbox solid, I think you can get like quite accurate data as well. Just by, let's say, checking the solid from the outside, as we can see right here, or clicking on the solid, uh, clicking the clip button, and we can once again also cut open the airbox if we want to. So yeah, let's cut it open in the middle here. Enable the magnetic flux density visibility, and we can also see how the magnetic field looks like inside of the airbox. Cut it open in some kind of an other way as well. So you're free to do that, and you will probably be able to see quite a bit of some interesting things perhaps. But yeah, then to actually make the field lines visible, if this is not enough for you, or you just want the results to look a bit more presentable, then what you can do is click on this solid. Once again, go in the filters selection. I will press Control Space to open the filter search bar and write in Stream Tracer. So yeah, here it is, Stream Tracer. Click on it. And here we will have a couple of things which we have to change before we actually before we will actually see the um, magnetic field lines. So here on the left, the first thing to change is the vectors should be changed to magnetic flux density. Then if we scroll down a little bit, here the seed type should be changed from line over to a point cloud. And actually at this point we can just press apply so that we can see already what's happening. So yeah, here we can see the magnetic field lines, but this is not the end of the filter, because we still have to apply some additional values. So yeah, so here for this point cloud, you can actually see that it's quite small in this case. So what we can change here, where we have the radius, we can change the radius of it, which will change the size of it. So if the radius is 0.013, I will increase it to 0.05. So that's roughly 3 times. Press apply, and we can see that the point cloud is a lot larger, and the magnetic flux, magnetic field lines, have also been developed to be longer. Then the next thing to adjust here would be the number of lines. So that's actually called here as number of points. So the original value is 100, but we can increase that to, let's say, 500, press apply, and we can see that more lines have developed. If we scroll down a little bit more, so we can also change the coloring to be either solid color. So actually, yeah, in this case, it's white, but you can also edit it to be, let's say, green. Or I personally like to have it have the coloring of the magnetic field as magnetic flux density. So you can actually monitor the strength of the magnetic field as well as have these nice looking lines. Yeah, another thing which I usually change is the opacity, since sometimes these lines can be quite difficult to see through. So you can change the opacity for them to be smaller, so they look kind of lighter, and you can more nicely see what's happening on the inside of them. You can actually also move around this point cloud. You can see the center of it right there, so I can move it somewhere else. Press apply, move it again somewhere else, and press apply, and you can see like, yeah, the way how the lines are visualized will change a bit, but still the like the strength of the magnetic field lines and their general direction will still be exactly the same. Um, yeah, and of course for these lines, we can actually also edit the color map to perhaps make it make the visibility for the particular particular spectrum that we would like to see a bit better, change the coloring, and so on. Yeah. So yeah, so I think for the since we are slowly moving to the end, I can just show you, since we have once again made like even more filters than we did before. What we could do now is just split this up into multiple windows. So once again, you see some kind of an example of how we can split this up so that we can like make these results a bit more presentable. So let's say this will be our general view, and then I can split the whole thing vertically, and here on the right I will have two extra windows. On the top one I will have, let's say, the hardened profile with a solid color, so you can see how it develops. And on the bottom one, let's say we will have the entire simulation, so the workpiece, which would be cut open. Then yeah, of course, remember that you have to also select the temperature for each thing that you add there, just so it shows us the temperature actually, not just the current density. And also, yeah, so kind of like this, or I can actually have the stream tracer here. Once again with the magnetic flux density, so something like this, so we can see that there. And on the right, we can perhaps disable the stream tracer and just have the entire thing kind of like this. And once again, we can go to the file, save animation, and just save this whole thing in pictures as it's moving along. One thing to point out, when you do go in that save animation option, make sure that everything here is exactly as you would like it to be. If some kind of like, let's say if you have some kind of a slice filter and you still have your mouse on that clip filter, this red box will also be extracted out in the results. So that's usually not what we want to see. Also here for the stream tracer, where we have this magnetic flux density window, we can actually go to the um, stream tracer filter, and we can deselect the visibility for that for the for the strength map there, as well as for the workpiece. For these clips, we can also disable the visibility for the strength map. But yeah, this is more or less it, at least from my side. I believe it's quite a bit of information that I have given you. But yeah, I would recommend that you try to set this up for your cases. There's many ways how to do it. The temperature probes, the cuts, pretty much, yeah, all kinds of ways. It's just the only limit is your fantasy of how you want to prepare the result. Okay, I see that there are a couple of questions in the chat box. What effect does the size and position of the sphere play in the stream tracer filter, and what should be this and what should the sphere be larger than the area of focus? The size of the sphere, I can actually just show you that as well. So actually the size of the sphere will kind of impact also how long the lines are in general. So what I could kind of show you, if we make the, let's say, the radius of the stream tracer filter even larger, so here I have 0.05, so let's say 0.15, a moment, apply. So right now it sort of tries to distribute all of those lines in a larger kind of a like circle, and then you can see that it kind of doesn't look as well as it does. For the radius of the sphere, I would say just make sure that it sort of like includes the whole system, or at least the area that you're most focused on, and it should make the results visualize nicely. So here you can see I have sort of like got the entire system which I'm interested in this sphere, and that's pretty much an optimal size for it. If I make it too small, let's say change it to 5 times smaller, what you will see will be the limitation that it sort of puts all of these things in like a small sphere, and you don't really see the entire view of the magnetic field. So these lines, they will be correct, but you can see that the strength of them is also like quite high here, and you don't see the whole picture. So I will just change it back to how it was right here. So just to summarize, make sure that it sort of includes the whole system, or the place where you think the magnetic field is the most powerful, and it should be okay. Don't go into like extremes of having it too huge or having it very small. Also remember that the limitation here is the actual airbox. So here where we have the airbox, actually the magnetic field lines, they won't be able to go out of the airbox. So that's also something to keep in mind. Yeah, the next question, I hope I responded to that. If you need me to elaborate more, let me know. But yeah, next question. Could you show us, please, how to display the magnetic field intensity, field strength, amps per meter in a given point versus time? Yeah, that's actually that's not something which I usually do, but I think that should be possible to do very easily. If we re-enable those temperature probes, which we had there in the beginning, let me select the line chart view and the initial probes. Yeah, so here I have all of the data of the probes that I made at the very beginning. And if we go here for the options of what we can see, actually also for the temperature probes, you can choose if you want to see something else there. So you said magnetic field intensity, oh, amps per meter. Um, Actually, I'm not sure if that exact option is able to be visualized. I would have to check. Yeah, I think perhaps that option would require some kind of an additional filter just for that for that exact for that exact units, for those exact units that you're asking. But generally, the magnetic flux density at a certain point just gets shown in exactly the same way as temperature probes. You just go on the left there and select what exactly you would like to see there. But yeah, about those specific like units, I'm not sure how that could be nicely shown. Perhaps this one. Yeah, so I'm not 100% sure about the units though. I can ask my colleagues if that's a feature which we could implement. But yeah, you can perhaps let me know if this is enough, or would those units be of high importance to you? Okay. Yeah, next question. If it is necessary to check losses in the inductor, to, for example, predict cooling afterwards, what should we do? So to check the losses in the inductor, I would say the very first thing to do is to, for example, just go to the time charts and understand like how much power actually gets induced into the vortex. So here we have the total power, which is inductor plus vortex. There, then we have just the vortex and just the inductor. So that's kind of the on the surface thing to check. But about the like visual things which you can check on the inductor, I would recommend that you check the current density and see if that is like something which is within applicable limits to you, or is it perhaps something which is too much. Then you can, of course, if you see the current density there, then you can see yeah, how um, so that's probably a place where more temperature will also develop, and some kind of like problems might occur to the inductor and so on. If you run also full thermal analysis of the inductor, so that will be cooling on the outside surface and the inside surface, you can probably also check the temperature for the inductor. Um, but yeah. About the losses, that's at least the initial things which I would check. Another thing, of course, which you can check, if we go to the main menu, so here where we have the visualization, you can also open the CSV file to see the resistivity, like resistance and inductance values depending on time in the inductor, as that might help you as well, at least. Certainly hope so. So here in the CSV file, we just go on the very bottom, and here where we have the like inductor associated things, the impedance, inductance, and resistance. So this might be something which you're looking for as well. So we can see how they change depending on time. So yeah. Yeah. Any other questions at this point? Also, something which I can mention, of course, as always, feel free to reach out to us in the support live chat, as we might be able to help you find some kind of options, or yeah, some kind of more advanced features of Paraview. Okay. Okay. Yeah. If there are no more questions, then that's it from my side. I hope you learned something new, or perhaps found some new ways of doing something which you've been already doing. But yeah, thank you for attending.